Last thing that we will do in section 1.8 is to try to find the domain of a composite function. Just like regular functions have specific values of x that cannot be plugged in, the same thing occurs with composite functions. In order to determine what values of x are allowed for a composite function, you first need to figure out what values of x are allowed for the inside function, and then determine what values of x are available to use for the composite function. So to start off, we're looking at the function f of g of x. And we want to know what is the domain of this function. So again, the first thing that we need to do is determine what values of x can be plugged in for g of x. G of x is equal to 5x. There's no restrictions on the domain of 5x since we're not dividing by 0 and we are not taking the square root of any negative numbers. So the domain for this would be all real numbers. The next thing that we need to do then is figure out what the composite function would be for f of g of x. Remember that f of g of x is equal to f with g of x plugged in for its input. So for f of x, we have 1 over 16 minus x squared. But where we have our x in that problem, we're now going to plug in the function g, which is 5x, and square it. This is going to simplify to 1 over 16 minus 25x squared. Now, as far as the domain goes, we need to make sure that we're not plugging in any values of x into our composite function that will cause this denominator to be equal to 0. We do have a denominator but no square roots, so we just need to make sure that the denominator, or 16 minus 25x squared, does not equal 0. Moving the 25x squared over to the other side, an equivalent statement would be that 16 does not equal 25x squared. I can then divide both sides by 25, giving me that 16 over 25 does not equal x squared. And then taking the square root of both sides, this ends up giving me that x cannot be equal to plus or minus 4 over 5. When you're taking the square root of a fraction, you can take the square root of both the numerator and the denominator separately. Square root of 16 was 4. Square root of 25 is 5. And then we get the fraction there. And don't forget your plus or minus. So we didn't have any restrictions from the first part, g of x, but we do have restrictions from the composite function itself. So the domain of this function, this composite function, will be that x is an element of the real numbers. Remember, this is our symbol for element of. And then now one of the symbols I'm going to show you is this symbol here. It's an R with 2 lines, and it's another way of saying all real numbers. Except we now have learned that x cannot be equal to plus or minus 4/5.